Hi everyone, my name is Irfan Ahmad. I'm the Chief Technology Officer of CloudPhysics and one of the co-founders. I also run the product management and the engineering teams here. Before we started CloudPhysics, I was at VMware for about 9 years and worked on several products, including the most recently released storage DRS and storage I/O control products. I was the tech lead for the DRS team that brought these products to market. Before that, I worked on ESX and the virtual machine monitor over my time at VMware. Having worked with some of the folks who ended up starting CloudPhysics at VMware for all those years, I realized that there was a significant gap between the products that I was helping design, research, and build and bring to market at VMware, and how my friends who were on the other side actually operationalizing these products and how they were able to quickly bring them into their data center and to use them. And what we as a team realized was that there was that huge gap between the capabilities of the product and the ability of our customers to operationalize. So that's where the origins of CloudPhysics come from. Now, the world today is full of data analytics. So whereas Target is able to figure out the buying patterns of its customers to the point where, if you recall, there were scandals about this a little while ago, where a father was able to discover for the first time a certain set of things about his daughter through Target, realizing that a change had happened. And the same thing applies with Facebook being able to now more and more reliably predict how relationships are going to work out. Google and Twitter are both getting very good at predicting outbreaks of flus around the world. So that's what we experience as consumers, that's what we experience as citizens in our daily lives. But there's a remarkable irony here. The same Target that is able to do that level of prediction cannot keep their data center up and have trouble keeping their applications in a highly available configuration. The same retailers that do the type of data analysis of consumers have a lot of difficulty managing their IT spend and end up spending too much on IT in terms of capital expenditures and have very long mean time to resolution for operational problems as they arise. So that's the really big irony. So we decided to kind of look at this and see what the world of analytics looks like. So if you go to Google and you type in business analytics, you'll see millions of results. In fact, if you type in personal analytics, you'll see a lot of results as well, because that's an area where the consumer world has been going. But if you type in data center analytics, unfortunately, there's only 4,000 results. And so that is indicative, I think, of the lack of turning the power of IT back onto itself and using the power of data analysis to help our day-to-day operations. So the reality is that the data centers have evolved, but IT operations management tools have not. And they remain static, whereas the data center is becoming more and more dynamic. And so the challenge that a lot of IT operators, starting from CIOs to system administrators, are always grappling with is, can the private cloud infrastructure, can it match the efficiency of a vertically integrated data center like Google's or Facebook and others? And so sometimes in conversations with CIOs, we'll hear a sort of a vague goal to say, look, I would like to have my operations as predictable, as available, and as efficient as Google. If Google can do it, why can't I? The reality is that to be able to match the efficiency, availability, and reliability and predictability of those data centers, we have to use the same techniques that they're using. And so one of those techniques is the ability to aggregate a very large amount of data. Now, how is it that Google is able to achieve the efficiencies that it does achieve? So if we look at that a little bit, we realize that part of that is because they have a very large infrastructure and they instrument all of their applications and their computers and their equipment. And then they have a very large set of very smart people dedicated to doing those optimizations in their data center to improve availability, efficiency, and performance. But the reality is that most of us are running data centers that are not at Google scale, and we don't have a pipeline into the world's top universities to hire programmers to come in and improve our infrastructure. That's not going to happen. That's not in our business model in commercial IT data centers. However, we can apply the same techniques still, and this is what CloudPhysics is doing. So there's 500,000 virtualized data centers around the world. That's how many customers VMware has for its data center products. CloudPhysics is connecting these data centers together and collecting the machine metadata from those data centers and putting our data scientists to go to work at it and to learn the patterns and to help using that massive global data set to help individual IT organizations improve their lot. So that's what CloudPhysics is about. Now, how it works. We're very focused on making sure that the ease of use of this system that we've described is not burdensome. So within 5 minutes, you can connect your data center to this SaaS. By downloading a very small virtual appliance, a few hundred megabytes, we sometimes even go on WebEx as customers are installing it, just to check to see, what is the customer's experience in the installation process. And we find within 5 minutes, you have downloaded the virtual appliance. If you go to vCenter, you can just click a couple of buttons and the virtual appliance self-installs, asks a couple of questions to get going. And connects to vCenter, connects to ESX, scrubs the data, encrypts it, compresses it, and starts to send it up to the cloud service. All of this happens by the time that you've installed it within 5 minutes and switched back over to the browser that you downloaded from, right? You're starting to see analysis results. So that's how quick and fast it is. And the nice thing is it's agentless, using only a single virtual appliance. By making it really easy to use, you get access to the results as soon as possible. Being a SaaS application platform means that when you use a web browser to connect, that you have access to hundreds of different applications that we have developed and our community members have developed to go and address key problems inside your data center. So just like on your smartphone, you may have a game, maybe you have Angry Birds and you have an expense tracking application. You tend not to use your Angry Birds to do expense tracking, right? There's a reason for the simplicity of the app paradigm. It's task-oriented. It's the best designed way to solve that one use case or that one problem or that one workflow. So we've adopted the same technique in our SaaS application platform, where whichever problem it is that you're having, we've got the best way to solve that problem. And it's going to look a little bit different than some other problem solution. So in one case, you may have access to some data using some filters. In another case, you might actually have a filter on a simulator that you can twiddle the knobs of, just like a flight simulator, and see what the results are. So each one of those applications, we call them cards on our platform. So each card is purpose-built to go and solve one set of problems. Now, CloudPhysics is using collective intelligence. So connecting to the world's operation data, having that available to our data scientists who go churn on it and give the results, analysis, recommendations back to our customers. But the key thing for us is that we don't want to inundate our customers with more data. The problem today is not the amount of data. That was the 1990s problem with the advent of Tivoli and other systems in operations management, because there was not enough data for IT admins to solve their problems. That's not the problem today. The problem is too much data and the lack of the ability to turn the data into something meaningful. So that's really our focus.
Irfan, one question about
yes.
with the turning over of data.
Yes.
I know a lot of people, especially when we use the word metadata, and our good friend Edward Snowden has made everybody aware what metadata means. How many folks do you find are resistant to the fact that you have that pool of data available to you, and maybe they're concerned about how much data is coming in there?
That's right. That's a great question. Every customer asks us, but we don't find a lot of stops from that. So we have customers that are in the financial industry. We have customers all over the world, Canada, South America, Australia, Canada. So on. That's right. So for those of you who don't know, Disco Posse and I are both Canadians. So but that question does come up, and it's actually very, very important to address it, and to address it very, very transparently and honestly. So first of all, the type of data that we're collecting is not the type of data that falls under any of the compliance mechanisms. So there's no SOX issue, there's no PCI issue. The way that the system works is you get to decide what privilege level that any data collector in your environment has. So that's a decision that you have. We cannot change that. And we request our customers to set up an account that has read-only access to the metadata inside your vCenter and ESX. So that's the first thing. We don't have access to the disk data. There's no way that we can even touch anything that's sitting on disk. So that's the first thing. The type of data actually turns out, if you look at other systems that businesses are already using to ship data in their business units, not just in IT, up to the cloud systems, this is the most benign type of data. So for example, a lot of our customers are already using Salesforce. A lot of our customers are already using ADP, right? And so, your employee list, right, and your payroll is already in a hosted environment or a service provider sort of environment. Your customer list is already in the cloud. Your credit card processing is already in the cloud. So for us, when we talk about the type of data that we collect and actually classify and list that for customers, very quickly they realize that this is not something that is an issue for compliance. The way that we actually store the data is very interesting. So we have a system of storing our data in two completely different systems as a result of our security architecture. The system that actually stores the details of your environment, the virtual machine performance statistics, for instance, and your configuration, is actually anonymized in the sense that if there's a random number that identifies each customer. And by having access to our entire database, you still cannot figure out who these customers are. You'd only be able to do anonymize analysis. Then we have our customer database, which is all about user records, your name, your company name, and so on and so forth, and that's stored separately, and there's a wall between these systems. So really, the security architecture is very carefully crafted to address that problem. And as soon as we disclose all of this information to customers, we tend not to have a problem. It's a great question. So CloudPhysics is using collective intelligence to provide answers. And it's a very simple formula that we have. We use our global data set, and we use our patent-pending data center simulation and resource management techniques, and we combine those two to have actionable intelligence, actionable analytics that are really the answers and recommendations to our customers. And ultimately, as I've said before, the objective is to get you the same sort of operational excellence experience that other larger environments have.
One question. You're taking all this data from all of these different data centers, and you're going to use that data to then make predictions on what other customers are going to be encountering.
Yes.
Is there any concern that the data that you're getting from these other data centers is bad? Like everybody's configuring this the incorrect way, so we're going to tell our customers to
go garbage in, garbage out.
Right, to configure this in the wrong way.
Yeah, so where we use a global data set is in a lot of different ways, but not that way.
Okay.
So we don't look at how everybody's configuring their environment to then tell you that you should also configure it that way. I mean, that's always, Krishna and I, our product management team, we always joke that, that would be, doing that would result in sort of this mediocrity, right? In fact, what you're looking for is the outliers, the people who have and data centers who are really well designed and set up, and you want to use those as references, not kind of the broad average. So definitely we agree with that. But an area that we can use a global data set, for instance, is understanding stochastically how different pieces of hardware respond to different types of stimuli. So, how does a storage device of a certain type and a certain configuration behave under stress? And we can figure that sort of stuff out by looking at the global data set in a way that each individual data center might not have pushed that limit yet. So that's an example of looking there. So the first element of that formula that I mentioned before is the global data set. So just to get a sense of this, right, a single data center with 50 servers and 500 virtual machines, and this is not a very large data center, right, produces 1 billion data points per day. And that ends up being about 25 gigabytes per day of data. And of course, we compress it so that that's not the amount of traffic that's going across the network, but uncompressed, that's 25 gigabytes. So you go across, you take this and you go across all the data centers in the world, and you're talking about hundreds of billions of data points every day. And the scale is absolutely massive. And just to demonstrate that, let's look at let's look at Twitter today with more than 600 million users. On a daily basis, 60 million tweets are sent. Okay. Hopefully, a million of those will be sent today.
Those right now,
yes, exactly. I was going to say we should be causing a spike right now. And if you look at Facebook, right, you've got 2.5 billion pieces of content generated. Now, if you look at 500,000 data centers around the world, that's off the chart on this scale, and you're looking at a quadrillion data points every day across the world. So that is the scale that our system is built to be able to handle. With that sort of scale, you can do a lot of improvements in how IT runs today. The last thing that I want to mention here is that data center simulation and resource management techniques, those are the techniques that the experts are inventing here and applying them to your data center. But the way that we do that expertise is that we will actually use our modeling expertise, but run it against the data set of the world. Okay, so that the results that you get have been validated against everybody else. An example of that is the HA simulator, where the HA simulator is a complete simulation of VMware's HA product. And we actually go through the details of exactly what the behavior of the system would be if you modified or tweaked any settings. Okay, and we put them in the simulator with knobs that you can twist and try out. Another example is the cache simulator that we have brought to market, such that individual IT teams can actually purchase that product and run it against their data center to get an understanding of how much SSD cache should they buy on a VM by VM basis in terms of the requirements, such that they can balance the performance improvement with their cost. So those are just two examples. Now, the answers that I talked about, they're across a whole bunch of use cases, and the ones that I wanted to highlight here include storage performance troubleshooting, proactive storage capacity management, which is actually a really interesting area I would like to drill into at some point in time. Health checks, availability diagnostics, SSD cache benefits analysis that I mentioned previously. We also have a really world-class custom reporting engine and for analytics that we'll talk about. Industry benchmarking. A lot of customers want to know how their environment compares against the rest of the world in terms of efficiency, for instance, consolidation ratios. Social sharing of analytics. Our community members have added about 300 of these applications on our platform. And also, more recently, a global field issues network, where as issues emerge around the world, we actually match those issues against individual customer environments and inform them before any problem can emerge and actually hit them. So that's a really interesting area as well.
So is that a packaged part of your service, or is that something that the customer has to pay more for?
All of
the analysis to get the data center simulator to run, or is that something that's done automatically when data is sent in?
This is all automatic. This is all part of the package, yes. So we have very, very simple pricing, very simple licensing model. It's on a per host, per physical ESX server basis. So you don't have to count VRAM. You don't have to be sitting there writing formulae to figure out how many vCPUs you have and all that sort of stuff. Extremely simple. The number of hosts in your environment determines the price of the service. And the nice thing is that it's a subscription service, so you're not sitting there with very, very long-term commitments to start to get the benefit of the service. It's immediate as soon as you connect. It's also a free trial, and the free trial allows you to take a full test drive in your data center. And finally, there is a community edition that at the end of the free trial you fall into, so you can still partake in all the community analysis that the community members are writing, including some of our tools, free as part of the community level.
What are the basic requirements out of the box? I mean, for folks that haven't touched it yet, what's your vSphere version that you're attached to? Any limitations on vCloud? And maybe you can talk, if you aren't going to now or later, about vCHS, if there's possibilities to extend that into those external environments if they're managed in our on-premises build. Is there a way for you guys to go in and grab data out of those field areas?
For sure. Several questions. So let me go and see if I can grab them. We'll talk about vCHS in a little bit, but we support vSphere 4.1 onwards, and certainly, we test as new versions come out. We go and test those, so that will continue to be the case. We are VCDs in our roadmap. We're collecting requirements for exactly what the relationship between VCD and vCenter the customers are looking for. So that's in our roadmap. We'd love to hear feedback. Please tweet us if that's a requirement for you. And some of the other things we're going to come back to in the next demo session.
Can I just ask you one question? This data is obviously of a lot of value, so typically it could be very useful to have like a professional services engagement coming off the back of that. So how do you view customers in terms of their understanding of maybe their environment already needs to be remediated in some way? So do you see yourself, for example, developing like a channel partner community or people who will work with you to kind of use that data to optimize those environments, once your software has been up and running for a while?
Yes, absolutely. So I'll address it now, and I'll also address it as part of the next presentation, so it gets recorded properly. This is a really, really critical question. I remember that David asked me this question a couple of weeks ago as well. The beauty of this product is that the service channel actually really loves this, because what they're able to do with this is to use the platform to land into a customer and immediately get a sense of the inventory there, about the key problems that their customer is having. So the trusted relationship between a channel partner and the customer, right, is actually made much easier, much better, much more fluid as a result of this tool. So we have, it's a tremendous amount of adoption that we're seeing in the service channel, with partners actually using this platform as a basis of their service. So yeah, I think you're spot on. We're seeing quite a bit of that.
And just one final question: is that something that those partners will license, or as a service, or how does that kind of commercially does it work?
Great question. So the way that partners work with us is that. So we can talk about the model, but the philosophy there is very simple. When our service partners make money, we make money. So we don't want extra overhead for them at all. We want them to use it, and as they make money, we make money. Right? So there's no upfront sort of, they don't have to buy from us to be able to use. We work with them very closely to make sure that that's low burden for them.